Video we will solve GATE 2023 EC problems. So in the first question they have asked to find out uh, based on the input output impedances the circuit behaves as whether it is VCVS, VCCS, CCVS or CCCS. Based upon the input and output impedances we have to determine how the circuit behaves. It is not like here input is voltage and output is voltage, so it will be VCVS. It is not like that. We have to find out the input and output impedances. So we know that for a MOSFET the small signal equivalent is this. GM the current will flow from drain to source, and this is gate, and gate nothing will flow. So to determine Rn we have to apply a voltage. To determine equivalent resistance at any load, R equivalent is V test by I test. We have to apply a test voltage and find out the test current. The ratio of them is R equivalent. To find out Rn, I will apply a test voltage Vt and I will find out the current It in terms of Vt. So while doing this, here VDD, the source is tied to VDD. In small signal it will be grounded and also the gate will be grounded. So VSG of this second transistor is 0, so GM VGS will be 0. So the current flowing in this transistor is 0 amps. So the current flowing here also should be 0 amps. That means GM VGS of this transistor has to be 0. GM VGS should be 0 implies VGS has to be 0. That means VG has to be VS. Here VG is tied to ground, so VS has to be 0 volts. So if Vs is 0 volts and no current is flowing in R1, that means this node potential has to be 0 volts, which is Vt is 0 volts. So we know that Rn is Vt by It. Here Vt is 0, so Rn is 0 ohms. So the input impedance is 0 ohms, and for output impedance we'll apply a test voltage Vt at output node and find out the test current It in terms of Vt. Similar to the first case, VSG will be 0, so the current flowing in the upper transistor will be 0 amps, and the current flowing in the lower MOSFET will be GM VGS, and the current flowing here is GM VGS, and this node potential, let us say it is Vs. Vs is GM VGS into Rs, so I can write this as GM to Vg minus Vs into Rs. I will bring Vs term to this side, so it will be Vs into 1 plus GM Rs is equals to GM Vg into Rs. Vg is 0 here, so this implies Vs has to be 0. We know that It is GM VGS, both Vg and Vs are 0, so It will be 0. So R out is Vt by It. Here it is 0, so R out will be infinity. If R in is 0 and R out is infinity, it will be a current controlled current source. These are the different combinations of input and output resistance and the behavior of the circuit. If input impedance is infinity and output impedance is 0, it is VCVS. If input impedance is infinity and output impedance is infinity, it will be VCCS. Similarly, R in is 0, R out is 0 implies CCVS. So here the answer is current controlled current source. This is also a simple problem. So we know that for inverting amplifier, the input is applied to negative terminal, which is like this. Let us say this is R2 and this is R1, this is Vn, this is V0. This will be grounded because of virtual short, and the current flowing will be Vn by R1. I is Vn by R1 and V0 will be minus I times of R2. So V0 is minus R2 by R1 times of Vn. This is standard result for inverting amplifier. Similarly, for non-inverting amplifier, the input is applied to positive terminal and the other terminal is grounded. So for that, similarly V0 will be 1 plus R2 by R1 times of Vn. So by this two simple rules, we can clearly see here that this is a inverting amplifier. So the output node voltage here will be minus R2 by R1 times of Vn, and this is a inverting amplifier, and the output node voltage here will be 1 plus R2 by R1 times of Vn. And here we have a inverting amplifier again. We can use superposition theorem to find out Vn. If I make only this input active, then the output will be minus R4 by R3 times this node voltage minus R2 by R1 times of Vn. And if I make only this voltage source active, that will be minus R4 by R3 times 1 plus R2 by R1 times of Vn. I have separated them, minus R4 by R3 into R2 by R1 times of Vn plus minus R4 by R3 times of Vn. These two terms will get cancelled out. So the gain V0 by Vn will be minus R4 by R3. The answer is minus R4 by R3. And here it is a simple diode clipper based question. Here they are sweeping input from negative to positive values, and we have to find out how the output waveform look like. To solve this type of questions, we have to see one thing. Let us say I have a diode and it is connected to some potential like this, V, or this is Vn. For this we need to find something called as which is breakpoint. Breakpoint is the input voltage where the diode changes its state given diode is open circuited. Let us say this is 2 volts and the diode has a cut-in voltage of 0.7. To find out the breakpoint, what I'll do is I'll open circuit the diode, then that voltage here will be 2 volts. For this diode to turn on, the input voltage needed is 2 volts plus V gamma, so the breakpoint will be 2.7 volts. So by this simple principle, we can find out when will the D2 turn on. For D2 to turn on, let us say this node potential is Vp, this node potential is Vn. For D2 to turn on, Vp2 minus Vn2 should be greater than V gamma. Here when we open circuit the diode, the node potential Vp2 will be 1 volt, so I have taken it as 1 volt minus Vn2 is Vin should be greater than V gamma. V gamma here is 0.7 volts, so Vin has to be less than 0.3 volts. When Vin less than 0.3 volts, V out will be V in plus V gamma. V gamma here is 0.7 volts. Similarly, for D1 to turn on, let us say this is Vp1 and this is Vn1. For D1 to turn on, Vp1 minus Vn1 should be greater than V gamma. Here Vp1 is Vin, Vn1 is 1 volt if I open circuit the diode. So Vin minus 1 should be greater than 0.7, that is Vin should be greater than 1.7 volts. In this case, V out is Vin minus V gamma. V gamma is 0.7 volts. Between 0.3 and 1.7 volts, both the diode D1 and D2 will be off. So here the slope is 1. At 0.3 volts, V out will be 1 volt, 0.3. Between 0.3 and 1.7, both D1 and D2 are off, so V out will be at 1 volts because no current flows. Here no current flows, 0 volts drop here, so 1 volt will be there. So at 1.7 volts, V out will be V in 1.7 minus 0.7, that is 1 volt, and it will have a slope of 1 after that. So the answer is this option. Okay, this question we have solved already in one video. So 1 milliamp, here 10 milliamp, here 10 milliamp, here it will be 5 milliamps, here it will be 7 milliamp, and 2 milliamp will flow here, so the output will be 2 volts. There are two more questions in 2024 2023 paper. Those are given as marks 12, so I'm not discussing them. So that's it. Thank you.